Control quality. Control quality is the process of monitoring and recording results by executing the quality activities to assess performance and recommend necessary changes. The key benefits of this process include identifying the causes of poor process or product quality and recommending and taking action to eliminate them, validating that project deliverables and work meet the requirements specified by the stakeholders necessary for final acceptance. Tools and techniques. We have four tools and techniques used in control quality: seven basic quality tools, statistical sampling, inspection, and approved change request review. First, we will discuss about the seven basic quality tools. The seven basic quality tools are cause and effect diagram, flowchart, check sheet, Pareto diagram, histogram, control chart, and scatter diagram. We will discuss each of the seven basic quality tools. First is the cause and effect diagram. This diagram examines why something happened or might happen by organizing potential causes into smaller categories. It can also be useful for showing relationships between contributing factors. One of the seven basic tools of quality, it is often referred as the Fishbone diagram or Ishikawa diagram. One of the reasons cause and effect diagrams are also called fishbone diagrams is because the completed diagram ends up looking like a fish skeleton, with a fish head to the right of the diagram and the bones branching off behind it to the left. Flowchart is a type of diagram that represents an algorithm, workflow, or process. The flowchart shows the steps as boxes of various kinds, and their order by connecting the boxes with arrows. This diagrammatic representation illustrates a solution model into a given problem. Check sheet. The check sheet is a simple document that is used for collecting data in real time at the location where the data is generated. The document is typically a blank form that is designed for the quick, easy, and efficient recording of the desired information, which can be either quantitative or qualitative. When the information is quantitative, the check sheet is sometimes called a tally sheet. A defining characteristic of a check sheet is that the data is recorded by making marks as checks on it. A typical check sheet is divided into regions, and marks made in different regions have different significance. Data is read by observing the location and number of marks on the sheet. There are five basic types of check sheet includes classification check sheet, defect location check sheet, frequency check sheet, measurement scale check sheet, and the checklist. Pareto diagram is a graphical overview of the process problems in ranking order from the most frequent down to the least frequent. It illustrates the frequency of fault or defect types. Using a Pareto, you can decide which is the most serious or frequent offender. The principle was developed by Vilfredo Pareto, an Italian economist and sociologist who conducted a study in Europe in early 1900s on wealth and poverty. It is a type of chart that contains both bars and line graph, where individual values are represented in descending order by bars, and the cumulative total is represented by the line. Histogram is an accurate representation of the distribution of numerical data. It is an estimate of the probability distribution of a continuous variable or quantitative variable and was first introduced by Carl Person. A histogram is a plot that lets you discover and show the underlying frequency distribution or shape of a set of continuous data. This allows the inspection of the data for its underlying distribution or normal distribution, outliers, skewness, and so on. Control chart. The control chart is a graph used to study how a process changes over time. Data are plotted in time order. A control chart always has a central line of the average, an upper line for the upper control limit, and a lower line for the lower control limit. These lines are determined from historical data. Control charts for variable data are used in pairs. The top chart monitors the average, or the centering of the distribution of data from the process. The bottom chart monitors the range, or the width of the distribution. If your data were shots in the target practice, the average is where the shots are clustering, and the range is how tightly they are clustered. Control charts for attribute data are used singly. The scatter diagram graphs pairs of numerical data with one variable on each axis to look for a relationship between them. If the variables are correlated, the points will fall along a line or curve. The better the correlation, the tighter the points will hug the line. The scatter diagram is known by many names, such as scatter plot, scatter graph, and correlation chart. This graph is drawn with two variables. Usually the first variable is independent, and the second variable is dependent on the first variable. The second tools and techniques for quality control is statistical sampling techniques are the strategies applied by researchers during statistical sampling process. This process is done when the researchers aims to draw conclusions for the entire population after conducting a study on a sample taken from the same population. There are concerns in statistical sampling. The first concern is representativeness. This is primarily concerned in statistical sampling. The sample obtained from the population must be representative of the same population. The reason behind representativeness being the primary concern in statistical sampling is that it allows the researchers to draw conclusions from the entire population. If the sample is not representative of the population, conclusions cannot be drawn since the result that the researcher obtained from the sample will be different from the result if the entire population is to be tested. Next is practicability. Practicability of the statistical sampling techniques allows the researchers to estimate the possible number of subjects that can be included in the sample, the type of sampling technique, the duration of the study, the number of materials, ethical concerns, availability of the subjects or samples, the need for the study, and the amount of workforce the study demands. The last concern in statistical sampling is sampling risks. There are two types of sampling risk. First is the risk of incorrect acceptance of the research hypothesis, and the second is the risk of incorrect rejection. This risk pertains to the possibility that when a test is conducted to a sample, the result and conclusion may be different from the result and conclusion when the test is conducted to the entire population. The risk of incorrect acceptance pertains to the risk that the sample can yield a conclusion that supports a theory about the population when it is actually not existent in the population. On the other hand, the risk of incorrect rejection pertains to the risk that the sample can yield a conclusion that rejects a theory about the population when in fact the theory holds true in the population. The third tools and technique is inspection. Quality inspection are measures aimed at checking, measuring, or testing of one or more product characteristic and to relate the result to the requirements to confirm compliance. This task is usually performed by specialized personnel and does not fall within the responsibility of production workers. Products that don't comply with the specification are rejected or returned to improve. The scope of quality inspections are, first, organization which uses quality inspection treats inspector as he was customer. The optimum form of quality inspection is a man who aims the best for customer satisfaction. Second, quality inspection serves three main purposes. identification of the quality problem, provision of information to managers, elimination of the problem by managers. Third, quality inspection can be performed at the end of production process or final inspection or at the several stages of the production called intermediate inspection. Fourth is that quality inspection is concerned on post-operative or post-production check of products. It doesn't have direct impact on production process. Quality inspector only sorts products, and he doesn't let poor quality products to leave the factory. Quality inspection has no feedback loop. That means that information about failures and their causes is not passed to workers or managers. Therefore, the system cannot improve itself. The last tools and techniques of control quality is approved change request. Approved change request review is part of change control, which is a project management process wherein all requests to change within a particular project is evaluated for approval, rejection, or deferment. Projects are defined by this life cycle, but change always happens. It is important that effects of changes such that the projects are maintained. An approved change request is a type of change request that has been processed through the integrated change processes. The change request is often submitted by requesters, reviewed by different parties, and approved by stakeholders of the said project. The approved change request can take effect at different points throughout the entire project process. It can commence at an early stage or at a much later date during the process, which can affect different aspects of project management such as budget and resource planning as well as quality of deliverables. The approved change request review is an important process because it lets everyone in the project knows about the changes and how they can adapt to it. While it is often applicable to big changes, minor ones can be implemented by the project leader without seeking approval from the stakeholders. Now we will discuss about outputs of control quality. The outputs of control quality are quality control measurements, validated changes, verified deliverables, work performance information, change request, project management plan updates, project documents updates, organizational process assets updates. Let's discuss the first output, which is the quality control measurements. The quality control measurements are used to analyze as well as evaluate the quality of the different processes involved in a project against the standards of the organization or on the requirements specified during the project management planning. The measurement can also be used to compare the processes that are used in making the measurements. It is also used to validate the actual measurements to determine their degree of correctness. Since quality control measurements are documented results, it is crucial that it be captured formats that are specified through the planned quality management process. It is also important to take note that this particular document is also an important input for the performed quality assurance. It is one of the inputs needed to generate change requests, product document updates, project management plan updates, and organizational process asset updates. This is to ensure that the quality standards as well as operational definition are satisfied. Next is validated changes. The control quality process is where change requests are validated. Verification that the change was implemented correctly takes place in the perform integrated change control process. The approved change requests are an input to control quality. Implementation of those change requests is reviewed. If the change requests are implemented as directed, they are validated. This process closes the loop on the change request process. Following the change request through perform integrated change control process, and then validating that it was implemented correctly on the control quality process may not seem like such a big deal. But when you're implementing a scope change, particularly a big scope change, you need to spend sufficient time making sure you understand the requirements, deliverables, resources, and risks associated with that change. The next output is verified deliverables. Verified deliverables is a project management term that is defined as the completed project deliverables that have been confirmed for accuracy and correctness using control quality process. While it is one of the outputs produced by the control quality process, its type of deliverables is also used by the validate scope process as one of its inputs. The validate scope process formalizes the acceptance of the project deliverables that has already been completed. Simply put, this type of deliverables is needed by different processes within project management. The verified deliverables are obtained from control quality. It is reviewed with the sponsor or customer to make sure that the deliverables have been completed with satisfaction and have received formal acceptance. This particular project management process, the outputs that are obtained from the planning process through the project scope management knowledge area becomes one of the basis for doing the validation that leads to final acceptance of the deliverables. Other factors used as basis for performing validation includes requirements documentations, scope baseline, and the work performance data from the knowledge area. The next output is work performance information. Part of executed project management plan includes the routine collection of work performance information. The information gathered is important. It is useful as input data for quality control measures and programs. It is also useful when audits, quality reviews, and process analysis are conducted. This is especially true of work performance information collected, which includes technical performance measures, project deliverables, status, required corrective actions, and performance reports. Gathering and analysis of work performance information is essential to the project management plan and should be considered a priority. Work performance information contributes to the efficient use of resources, identifies potential trouble spots and problems, and serves as an effective project management tool. Pertinent work performance information is essential to the project management plan and includes, but not limited to, status information and schedule progress, whether deliverables have been completed or not, start and finish status of scheduled activities, quality standards expectation results, authorized cost versus cost incurred to date, estimated completion time for scheduled activities in progress, percentage of physical completion of in-progress scheduled activities, experience based on knowledge acquired, documented, and posted to knowledge space, details of resource utilization. Next output is change request. A change request can be defined as any request that is submitted to whatever change control board or decision-making group has been implemented. This change request can consist of changes which range from minor changes to significant changes that drastically alter the project. However, typical formal change requests involve more significant changes, and the less impactful changes are made at the in-project management level. A typical change request can request a change to a number of project areas, including requests to extend or reduce the scope of the project, requests to modify policies, procedures, plans, or processes, requests to modify expenditures, and requests to update or modify schedules. Change requests can be made directly or indirectly and can be initiated internally or externally. One constant throughout most change request process is that change requests must be made formally, via a written proposal or request form typically, and that changes are not be implemented until they are formally approved. The next output is project document updates. These documents are used to manage the information which is not part of the project management plan. These documents are prepared by the project manager for his own needs. Out of these documents, only charter, contracts, and statement of work are shown to the project sponsor and is of interest to them. Project documents include project charter, statement of work, contracts, requirements documentation, stakeholder register, change control register, activity list, quality metrics, risk register, issue log, and other similar documents. These may not be included in a project management plan, however, are an integral part of the project. With a few exceptions such as charter, contracts, and statement of work or SOW, the rest of the documents are used by the project manager for his own needs. They may or may not be shown to the project sponsor. The sponsor will see and approve the project management plan. Next is Organizational Process Asset or OPA updates. Most organizations have developed a range of templates, contracts, registers, and assessment tools to assist the management of their projects. Organizations have also acquired knowledge in the form of lessons learned and the organization's knowledge base that can be very useful. Therefore, organizational process assets would include anything the organization has acquired that you can use in the management of the project. They include formal and informal plans, policies, procedures, and guidelines. These are very important for the planning stage, irrespective of the nature of the project. What, whether your project is long term or short term, OPAs are a must. Common OPAs are standardized guidelines, proposal evaluation criteria, work breakdown structure templates, project schedule network diagram templates, risk templates, organizational standard processes, project closure guidelines, defect management processes, lessons learned and historical databases, change control procedures, financial control procedures, project file. The suggested contents of a project management plan are executive summary, strategic organizational alignment, project scope definition, feasibility assessment and contingency plans, constraints, human resource requirements, material equipment requirements, project schedule and milestones, budget, cost estimate, risk management, project issue, change management, communication management, related products deliverables, approvals, attachments.